A little bit of algebra. We'll run into some other things as we go through, or we'll stop and do a little bit of review as we get there. We won't try to review every single thing we need to know from algebra and trig today. Okay, so don't panic about that. We're just gonna kind of hit some of the highlights today. So how many of you, it's been more than a year since you took algebra? Okay. A couple of 2, 3, 4, 5. That's why. No. Even if you start with 112 here, you have to take 112, and then you have a semester you take 113, and then you can get a little rusty on algebra stuff sometimes. Okay? I think, seems to me, a lot of people that think they're struggling with calculus are really struggling with the algebra that we use. So we want to try to firm up things from algebra that are common hangups, stuff that you forget. Try to get. So for the most part, a lot of the calculus we do in Cal 1 is really not hard, not like hard math. Some of it is long. Some of it has a lot of algebra in it. But as far as the calculus part, okay, the new stuff that we're learning, really not all that terrible in Cal 1. So who's nervous about taking Cal 1? At least half of you. Some of you kind of on the fence. We'll get through it. It's not like a big impossible class. You hear horror stories and things. Really not that. It doesn't deserve all the negative PR it gets. I'm gonna let. And we'll get into kind of gist of what we're going to be talking about a little bit right up. Most of what. Okay, so let's just let's go back pretty far. We'll go to the base. Got something like that. We want to multiply. Going pretty far back here. How would we multiply that out? What do we get? Well, we got a times b plus c. What do we end up with? Yeah, ab plus ac. You may remember what that's called? Distributive property. And so we say we got to multiply the a times the b and multiply the a. We can do the same thing in the other order. Okay, the order doesn't matter with multiplication. Works for real numbers. It's not that way. We can switch it around in every number system here, so we would get the same. You could write it differently, right? You could write it BA plus CA. But for us, with real numbers, the order doesn't matter. So they're really the same. If you're being real strict about it, you would call this left distributive property, this right distributive property. But again, with real numbers, order doesn't matter. So we'll just call it distributive. Okay. Quite often. Let's see. What about in basic? What do we have that situation? We want to do a plus b times plus d. You may, yeah, somebody, I think somebody. FOIL, yeah, FOIL. There's a little acronym we use for that. Say we multiply the first terms, the outer terms, inner terms and the last term. Really all that is its distributive property still. It just so happens we have two things we're distributing. So when we multiply, take the A times the C and the A times the D as first and outer. And then we would take the B times the C and B times inner and last. So what we end up with four terms plus AD plus and when we're dealing with polynomials, lots of times we have like terms. Sometimes in algebra class you get used to always ending up with three terms over here because you have terms in the middle that are like terms and you can combine. Not always the case with FOIL, but a lot of times it is polynomial. Okay. Anybody panicked yet? Okay, good. So let's think about add something raised to a power. Think about exponent rule. We want to take the product, A times B, raise that to the third power. How do we sort that out? What do we end up with there? It's okay if you be incorrect. What do you think? Oh, good, we're reviewing then. Okay. So have a product, you're raising that to a power, we multiply that times the exponents on the end. Have an understood exponent of 1 on the A and an exponent of 1 on the B. So it's kind of like distributing the exponent. So with A to the sometimes we'll remember that one, but when we'll forget it, if we have a situation like 2A to the, we'll forget to raise the 2 to the third power. This one, what we should get is common thing to get tripped up on. Another one. What's that one telling us to do? We got A plus B squared. So either tell me what we should do there or what we will end up with. Yes. So if we square something, that means it's multiplication by itself. We're going to end up with another way of writing the same thing is A plus B times plus B. And if we do FOIL, squared plus 2AB. AB and BA and combine those. Common mistake. What do you think? What do you think people accidentally do? They say it's A squared plus B squared. It's the middle term. And the same thing is true for higher exponents. We want to actually multiply this one out. At that is not A to the 7th plus B. what we would have to do with that, if we actually needed to multiply that out, there's actually a pattern you can use, short way, but if we were going to go through the motions and multiply the thing out, we would have to do what? That means a plus b, plus b, plus b. We would have to have 7 of those. We won't figure out what it is. Yep. No, because what happens, so yeah, there is a short way. It's using thing called Pascal's triangle. May I remember seeing it before. So we want to raise something to the first power. We get a coefficient of 1. Go down through the steps. So like when we squared that one, a plus b squared, our coefficients were 1 a squared, 2 ab, 1 b squared. If we raise it to the third power, we get a 1a cubed, and our exponent steps down on the a. We'll have 3a squared, add 1b, 3ab squared, 1b cubed. And then the same thing if you raise to the fourth power, there's your coefficients, and you do the same thing. You decrease the a's and increase the b. And you can do that for any, that's the main shortcut. So what would that be? Just for giggles, real quick. All you do to make the triangle, like here, 1 plus 2 is 3, and 1 plus 3 is 4. Here, 3, adding as you go down the triangle. Fifth power gets messy really quick. Sixth power, so seventh power coefficients. Ugly. You don't have to know Pascal's topic. Okay. Let's see what about what are we looking for when we say factor? We want to get two things we multiply together, factors, multiply together to give us x squared plus 2. Anybody remember what that one's going to be right off? Time to come back to you. Yeah, so the thing we do is we look for factors of this number that when we add those factors together, get, so factors of 2 of 1, sorry. 1 and 1, we don't have a lot to choose from there. If we add those together, we get 2, the middle number. So when we factor here, it takes x times x to get x squared, first terms, and then add positive 1 and positive 1. And if you use FOIL, multiply that out, you should get squared plus. That gets trickier when our numbers get bigger. Right? We didn't have a whole lot of factors of 1 to choose from. Just So let's add one idea to that. We had started off with this thing as an equation. Solve for x. It'll be we would factor, and then there's one way we could do it, and then what do we do next? Yeah, we said each factor equal to 0. Where there's a property that says if you have two numbers, that's all we have. This says this is some number times this number, and when we multiply, we get 0. So there's only a couple of ways that, well, 3 ways, I guess, that can happen. And that's unique to it equaling 0 on the other side. If this is some non-zero number over here, then this doesn't work. Have it equal to 0. The only way that can happen, the only way you can get 0 when you multiply is if this number is 0, right? 0 times something is 0. Or if this number is 0, something times 0, 0. Or there's one more option. Either the first number is 0, second number is 0, or what? They're both 0. Both 0. Because 0 times 0 is 0. So that's the property we're using. We could take set each factor equal to. And in this case, they're both the same. We get a repeated solution. We didn't want to factor. Sometimes factoring is our best option. We didn't want to factor. What else could we do there? What's another option for solving a quadratic equation? Quadratic formula. Quadratic formula will probably be useful some. Real quick. Quadratic formula. Solve any quadratic equation using that. Not always fun, but use it. So here, what's a, b, and c? Our coefficient for the x squared term is a. Coefficient for the x term is b. And constant term, this c. Plug into our equation here. And so the opposite of b, 2 squared. Have to be careful with the sign there. If that was -2, -2 squared is +4. So it's a good idea to put parentheses, b squared part. 4 times 1. 1. And then we just have a bunch of simplifying. We had a lot of the time on. This one's not too bad. 2 squared is 4 minus 4 times 1 times 1 is 4. If that happens when we have a 0 under the square root, that rational. That turns into -2. We already knew that because 3 major possibilities that can happen with a quadratic equation. You either get a real solution like that when we get 0 underneath the square root. Anybody remember what the part of the quadratic formula under the square root is called? Got a name. Say again. I'm sorry. Oh, not the part under the radical. B squared minus 4. You're right. The 2a's the b squared minus 4ac has its own name. Anybody remember what letter it starts with? The discriminant. I think that's right. tells us what type of solution we're going to have. So we either have a real solution, or we'll have like a whole number there that we had, or we could have complex solution, which we're not going to care too much about in this class, or we could have an irrational solution if we have a radical. It's still real, but irrational. Just something you can look at. There's nothing that's mandatory that you excellent mastery. All right, just two other ideas I can think of. Go. So we have, let's talk about rewriting. We go through this class, a lot of times it's going to be helpful for us to just keep the same meaning with whatever expression or equation we're given, but it'll be helpful to rewrite it in a certain way. So we want to be able to manipulate some things algebraically. One thing we want to be able to rewrite radical expression. What's another way we can represent radical? Instead of having the radical there, we can exponent. Yeah, when you rewrite it with an exponent, yes, and for square root, yes, the exponent would be 1/2. So a radical we can rewrite as a fractional exponent. And our rule there, another example. Rule here is that whatever the index is on our radical, that's the denominator of our fraction. On square root, it's just understood to be. And then, you may not have noticed it here, but exponent on whatever is underneath the radical, so it goes in the numerator. So then if we squared, and in exponent form, what's that one going to be? X is 2/3. 2/3. So that can be really helpful. We just have situations where radical form is easier to think about and work with, and we have situations where exponent form is easier to think about. Here we get to use all of our exponent rules. This one's actually like thinking about 2 to the 1/2 power is harder for most of us to think through than saying square root of 2. So radicals can be helpful, but exponent form can also. And one other major rewrite I'll be able to do. What if we x to the negative 3rd power? What if we want to get rid of the negative exponent? Yeah, that's right. It'd be 1 over x. So if we flip, you can think about it like flipping, or if we take a term and we move it across the fraction bar, changes the sign of the exponent. That direction won't come up as much for us. What will be really helpful is when we have one like this, and we don't want that x to the 5th to be in the bottom, we want it to be in the top. So same idea, we move it from the bottom up to the top, just kind of the reverse of the first one. What are we going to end up with there? X to the negative. And you could think about x to the over 1. Same idea, we're just, and then what if that's not a 1 up there? How could we move that x to the 7th to the top? What do we end up? negative 6. Right. Nothing changes with the 2. It's staying in its spot, right? It's in the numerator. Just be a little careful. Sometimes XSC, like if we had this one, 1 over x to the 5th, it's the exponent that changes sign. This is not. Changes sign of the exponent. Careful with. Oh, so just for completeness. We want to do both things. So if we want to get rid of the radical and move it to the numerator. Yeah. Yeah, so if you do it in 2 steps, we'll get rid of the radical, let's say. We move it to the top, we make it negative, so try to refresh yourself on those properties. Nothing too super intensive on any of that, okay, but it's stuff that's easy to forget. We'll need every bit of that. If we run into bigger things, like I said, we'll take time and do a little bit of review as we need stuff. What is it? Is easy to forget some algebra. I don't want algebra to be your hang up. Don't want algebra to be the reason why you feel like you're struggling. All right, so Friday we'll actually get more of an idea about what calculus is all about. Okay? Anybody taking calculus in high school or something like that before? You've already seen some of it? A couple of you? You won't be as surprised. But it's brand new to you. It's pretty interesting. Pretty interesting what we're doing here. Okay. All right. I will see you Friday. I'm here if you need to talk about anything with me.